Son las 9:17 de la tarde, hora central europea. Nosotros muy pendientes a las imágenes que va a compartir la NASA en relación al radiotelescopio también de MeerKAT en Sudáfrica, que ha realizado el 5 de noviembre esa búsqueda de transmisiones de radio de banda estrecha provenientes de ese objeto interestelar del que tanto se hablaba, del 3 y Atlas. Han utilizado ese sistema de blues apto para la búsqueda en tiempo real de las señales tecnológicas de radio. Vamos directamente a escuchar las palabras de la NASA, de los miembros de la NASA.
Questions from the media on the phone bridge and through social media, but before we get started, let's learn more about the fascinating comet and share some images. Ahmed, kick us off.
Hi everyone. America leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025 to the Minor Planet Center. And NASA has been tracking and studying Comet 3I Atlas ever since. We're here today to give you the latest of what we know about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small, natural, solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star, like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet. It looks and behaves like a comet and all evidence points to it being a comet. But this came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found. And a little bit more about the rumors. I think it's very important, and I'm actually very excited that a lot of the world was speculating about the comet while NASA was in a period where we couldn't speak about it due to the recent government shutdown. I think what I took away from that whole experience and watching that as we were working during the shutdown was just how interested and how excited people were about the possibility of what this comet could be. There was a lot of speculation about what it could be, but what I think is really awesome is that folks were interested in this incredible finding that we observed and that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains to think about how magical the universe could be. And I'll tell you, here at NASA, we think that every day. And so it's really great that you were able to join us while we were, not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share with you as much as we can. In fact, we want very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars from our amazing machines that have been roving the planet for 30 years to look for those things.
Pues ahí escuchamos la conexión desde Washington DC. Precisamente estaban hablando los miembros de la NASA en que posiblemente podrían encontrar vida en el resto del universo. Los científicos dicen que están cada vez más cerca de buscar señales de vida en el universo, que están ya practicando y trabajando en ello, que podría ocurrir también en Marte, y que los últimos estudios han apuntado a que podrían encontrar los indicios en nuestro planeta, también en nuestro planeta vecino Marte. Nosotros que vamos a continuar hablando del 3 y Atlas con nuestro compañero Sergio Fernández. Enseguida vamos a ir con él. Mientras tanto, sí que señalar las declaraciones que acaban de hacer desde Washington debido al cierre del gobierno. Dicen que no han podido publicar todo lo que querían acerca del 3 y Atlas y que están cada vez más cerca de llegar a esos últimos estudios que apuntan a que podría haber vida en nuestro planeta cercano Marte. Vamos a escuchar a Sergio Fernández hablando de ello.
Buenas, Valeria. Seguimos atentos a la señal que nos está llegando desde la NASA. Vamos a ver la señal en directo hablando del 3 y Atlas, dando imágenes inéditas de este cometa.
Science wiggles, where the instrument, the spectrograph, the ultraviolet spectrograph on MAVEN, has looked at the comet and also split up the ultraviolet light according to color. So you're seeing three different bands in this image. On the right, you're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's a fainter band indicating that's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from comet 3I Atlas. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet, there would be no little blob on the left side of the image. But it's also telling us it's one of the many ways that we're able to discern the chemical composition of 3I Atlas. And in this particular example, it's showing us the hydrogen gas that's coming off of the nucleus. Now, MAVEN's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate, how much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy. Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I Atlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the Sun. Comet 3I Atlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before.
Están viendo la imagen que nos llega desde la NASA con precisamente fotografías, imágenes inéditas del 3I Atlas que, bueno, pues están de alguna forma respondiendo a las teorías de Avi Loeb, el científico de Harvard, que decía que, bueno, que esto podía ser una nave alienígena. Daba también informes, daba argumentos para de alguna forma sustentar estas teorías. Pues la NASA responde a estas teorías, a estas polémicas, dice que el 3I Atlas es un cometa y está mostrando imágenes exclusivas. Seguimos escuchando lo que nos llega desde la NASA.
To then making sure that they are accurately calibrated and processed to do science with, and then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. But the answers will come later on. We are still at this phase, very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. This is a snapshot of where we are very early in the scientific process. Okay, back to you, Courtney.
All right, thank you all for your opening remarks. We'll go ahead and start the question and answer portion of this event. Just a reminder to our media on the phone bridge to press *1 to enter the queue and ask your questions. We'll take our first question from the phone bridge from Marcia Dunn with the Associated Press.
Yes, hi. Based on your latest observations, what more can you tell us about the potential shape of the comet? Can you fine-tune any more on how big or small it might be, origin, all that sort of thing? Thank you.
Thanks for that question. There's a lot of territory to cover there, so let's see what I can do. The size of the nucleus still has yet to be pinned down. The best data are still from the Hubble observations that Sean was talking about. So we're still right now in that range of somewhere in the vicinity of a couple of thousand feet to a couple of miles diameter, but we'll get better on that one.
Empieza el turno de preguntas para la NASA. Avisamos a nuestros espectadores que a través de las redes sociales pueden usar el hashtag AskNASA, donde, bueno, pues pueden ir poniendo todas sus preguntas acerca del 3I Atlas. La primera pregunta es de Associated Press, que está preguntando sobre el tamaño del 3I Atlas, una de las cuestiones que más polémica está sustentando. Algunos dicen que es algo así como la ciudad de Manhattan. Esta es la respuesta de la NASA.
That would be an indication of rotation, and it's very difficult to discern. So what it's looking like so far is that there's not a big the shape of the nucleus is not very far from being round. Doesn't seem to be a big, or at least we're not seeing signatures of a very elongated object yet. There's a lot still to come there. I think you were also talking about origin. it would be great, it would be fabulous if we could trace back the incoming trajectory into the solar system and trace that back and figure out where it came from. But things are not quite so simple. Our galaxy, as Sean knows, is a big and complicated place, and the sun and all the other stars in our galaxy are in orbit around the center of the galaxy. And so 3I Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in.
Escuchamos a este científico hablando sobre el tamaño del 3I Atlas. Es una de las cuestiones que ha puesto encima de la mesa en repetidas ocasiones el propio Avi Loeb. La clave está en el núcleo. Nos decía hoy Avi Loeb en su último informe en Medium que la clave está en el núcleo, que bueno, va a dar pistas. En este caso el científico está pues refutando estas teorías y nos viene a decir que el tamaño es normal. Saben que 1I, Oumuamua y 2I Borisov no tenían nada que ver en cuanto a tamaño con este 3I Atlas y es precisamente una de las cuestiones que más polémica está suscitando. De momento la NASA echa balones fuera.
All right, we'll take our next question from the phone bridge from Bill Harwood with CBS. Bill, if you're talking, we can't hear you.
Me again. This is Bill Harwood again. Can you hear me?
We have you loud and clear.
Okay, thanks. Sorry about that. Amit mentioned the rumors that were, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have two questions for anybody who would care to answer. One is, did any of you seriously, did you take seriously the proposition from some that this could be an alien spacecraft? I doubt you did, but I'm asking the question anyway. And number two, is there any evidence you see in any of the data you have that would fit an explanation like that? Or as far as you're concerned, does all of this data say conclusively that this is simply a comet that happens to be passing through the solar system? Thanks.
So I'll take that one, Bill, and thanks for the question. We love all of the different science and all of the different kind of hypotheses into what these things can be. When you start seeing something, you just got to point. It's natural to wonder what it is, and we actually love, as Amit said, we love that the world wondered along with us, and that's such a cool thing. We certainly were able, because of the measurements that Sean described.
Segunda pregunta para la NASA, ya sale el nombre, ya sale la teoría de Avi Loeb. Estaba diciendo este periodista que si en algún momento se han tomado en serio el hecho de que esto pueda ser una nave alienígena y también, pues venía a decir que estas teorías que se están publicando en las redes sociales, dice la NASA que es normal preguntarse y responde de esta forma, si es o no una nave alienígena.
Pretty well. You kind of know the signatures that you're looking for, and so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, Tom, I know if I throw this to him in a second, he's going to geek out about it. But the really cool thing about this is the differences, because it comes from somewhere else, and that's why we're so excited about it. It's only the third time that we've been able to identify and track something coming from outside our own solar system. We've long predicted these things occur, and now, of course, we know better how to look for them, and we now have this amazing Atlas array. We're expecting we'll find a lot more of them, but it was quick. We were quick to be able to say, yep, it definitely behaves like a comet. We certainly haven't seen any techno-signatures or anything from it that would lead us to believe it was anything other than a comet. But the super cool thing is not that it's exactly like all the comets that we see in our solar system. It's the differences that are so tantalizing for us as it gives me goosebumps too. It could be from something that existed before our own solar system. That is so cool. It's from something that predates even our own star. Yep, it's going to look different because it didn't come from our solar system, and that's what makes it so magical. You want to geek out a little bit, Tom?
You were geeking out so expertly, Nikki, to begin with. So that was fabulous. But that's exactly right. I mean, things from other places, we naturally expect them to be different from our own homegrown variety. And I like to imagine
Llega la respuesta por parte de la NASA ante estos comentarios de Avi Loeb, esta pregunta de si es o no una nave alienígena. Dice la NASA que no han visto absolutamente ninguna muestra tecnológica. Decía antes que es normal hacerse preguntas, pero que, bueno, que todo lo que han visto desde Tres y Atlas indica que es un cometa. Refuta todas las teorías la NASA. Bueno, pues sigue echando balones. Es un cometa, que no hay nada tecnológico, no hay nada raro en este Tres y Atlas. Vamos a seguir escuchando sus explicaciones.
Bless them. Of course not, but it's different, and yet it's still coffee, and that's what we have in this case. We have a cometary body. It behaves, it resembles the homegrown comets that we have in our solar system, and yet it's excitingly different in particular ways. It does the same things comets do. It evaporates carbon dioxide gas. It evaporates water, but it's evaporating more carbon dioxide compared to water. So that's a very interesting thing. Comets evaporate dust, and the dust is broken down. The minerals are broken down by the ultraviolet light of the sun. And comets, we know comets put out nickel, they put out iron. That's what comets do. This particular one is putting out more nickel than iron. That's really interesting, really remarkable, and something to be studied in the future. So we're always interested in new ideas. We're always interested in new suggestions, and all ideas are good when they're born. But those that stand the test of time, those that stand up to testing, those that are supported by the evidence, are the ones that survive.
All right, we'll take our next question on the phone bridge, and that one comes from Matthew Glasser with ABC.
Good afternoon. Thank you for doing this. Tom mentioned that the answers will come in time. I'm curious about what are some of the hopes that we might discover from this comet. What might it tell us about our planet, about our solar system, about the universe?
Seguimos escuchando más explicaciones por parte de la NASA acerca de este Tres y Atlas. Sigue la rueda de preguntas y ojo, porque empiezan a admitir alguna cosa que se sale de lo normal. Nos estaba explicando un científico que, bueno, pues que este Tres y Atlas tiene más níquel que hierro. Dice que es algo muy interesante, que es algo que no pasaba con los otros cometas y que es algo que seguramente se estudie en el futuro. Avi Loeb ha hecho mucho hincapié en precisamente esto, que la composición, la parte de níquel y de hierro que tiene, pues que no encaja, que se sale de lo normal. La NASA, bueno, pues está aceptando estas ideas de Avi Loeb, pero sigue diciendo que es un cometa, que no ve nada tecnológico. Vamos a seguir escuchando este turno de preguntas para la NASA.
Tremendous amount of information from hundreds of years of astronomical observation and from decades of in situ spacecraft observation has revealed our planets as actual places, not just points in the sky that you could barely see with your own eyes. We've learned about comets and asteroids, and we're beginning to put together a picture of how all of those planet-forming minerals and planet-forming ices came together to form our planets, and how our solar system changed over time. Just one example, we get a fascinating clue from the objects like Pluto that we've been discovering since the 1990s, the trans-Neptunian objects. The way they are distributed through space in the outer solar system show us clues to how the orbits of the major planets may have changed over time in the early solar system. A fascinating thing, and questions that we would never have thought to ask before we knew about these trans-Neptunian objects. Now, interstellar objects, like I said before, are new windows, and it's windows that we've never even looked out of before. So what we're going to find is way too early to predict, but I think we're getting a hint of the breadth, the wide spectrum of conditions that existed in different parts of the galaxy, in different solar systems, where the compositions, the elemental abundances, the mineral abundances may have been very, very different. It would be a different picture if we were seeing the first three interstellar objects and we'd say, gee, those look exactly like our homegrown comets. That would have been really interesting, and we would have said, well, maybe our galaxy is a boring place because every place is the same. What we're seeing with this is not every place is the same. That's a good thing. Lots of places to explore, and they will be different if we ever manage to get there.
Yeah, I think of these as frozen fossils from their moments of formation, including the things in and now from beyond our solar system.
Sigue este turno, sigue esta rueda de preguntas hacia la NASA sobre el 3 y Atlas. Y bueno, una de las preguntas que todos nos planteamos es ¿para qué va a servir esta observación? ¿Qué va a cambiar la llegada de este 3 y Atlas? Están diciendo, bueno, pues que lo cierto es que está dando nuevas pistas sobre la galaxia, que está trayendo nuevas ventanas sobre las que podemos mirar y sobre las que podemos aprender de cara al futuro. Seguimos escuchando más respuestas en este turno de preguntas para la NASA.
And now with this visitor that got frozen in time from somewhere beyond our solar system, and that small picture of what that was like when that formed.
And the fact that, I mean, I love the sort of thought of it as that frozen fossil, almost frozen time capsule. We're kind of privileged. I mean, it's come into our solar system, our sun. We know, we think it hasn't seen a star for a long time. So it's actually warming up and giving us more information. It isn't just about a frozen object coming through and us sort of saying, oh, look, there's a frozen object moving through. But as it's almost waking up and showing us its composition, and that's allowing us to be able to do this great science. If it had just remained frozen all the time, we wouldn't know much about it. But it is the sort of its rendezvous with our star that is allowing us to really do this amazing science. And that to me is, it makes me feel almost privileged to actually be able to unlock the secrets as this cometary object is coming around and rendezvousing and interacting with our solar system.
All right, let's head over to social media. Nina on X asks, will it hit any planets in our solar system?
No, it will not. I think if you, obviously we're not going to run it again, but please, go online, take a look at go.nasa.gov/3i-atlas and take a look at the trajectory. I kind of talked through it briefly.
Bueno, la NASA que está hablando del privilegio que tenemos con este 3 y Atlas, bueno, pues hablando también del turno que ahora llega para las redes sociales, les volvemos a repetir, hay un hashtag llamado AskNASA donde pueden ir formulando todas sus preguntas. Están haciendo en este momento la pregunta que todos nos hacemos, si en algún momento el 3 y Atlas va a impactar en el sistema solar. Incluso había algunos que estaban jugando, estaban poniendo la idea de que pudiese impactar contra la Tierra. Fue preguntado el propio Elon Musk, el CEO de Tesla, que decía, bueno, que podría arrasar un continente entero. Esta es la respuesta de la NASA refutando estas teorías. Dice que la trayectoria no apunta a la Tierra, menos mal.
Discovered in 2017 that was one eye, Oumuamua, that behaved very much like an asteroid. Again, a little bit like 3I Atlas, a very interesting asteroid, in some ways different from the asteroids we're accustomed to seeing in our solar system. For one thing, it was seemed to be very, very elongated, and while it was inactive, it seemed to be an inert, mostly rocky object. It did show indirect indications that it was evaporating gases in some way. It wasn't around long enough for us to get really, really comprehensive, long-duration observations and understand exactly what it was doing. It was the very first one. We saw it for a short time when it was on its way out, in fact, and so we didn't get a great view of that. The second object, 2I Borisov,
siguen formulando preguntas, en este caso a través de las redes sociales, y están cuestionando, bueno, pues algo que todos nos planteamos, ¿qué hace diferente a este 3i Atlas? ¿En qué se diferencia del 1i Oumuamua o del 2i Borisov? Escuchamos la respuesta de la NASA.
Properties were more in line with what we're used to seeing, and the comet observers regarded it as very much akin to our solar system comets, although in some ways a little bit at the edge of what we're used to seeing. 3I Atlas is in a lot of ways like 2I Borisov, but a bit more out there in terms of things like the carbon dioxide to water ratio.
All right, Svetlana on LinkedIn asks, will the observational data from this campaign be available for open analysis?
Absolutely. Every piece of NASA data we are delighted to share. We've had open data policy at NASA for a long time. We make a big effort not just to release the data but also to make sure it's usable so you can get the tools and things to actually analyze the data as well, and we invite everybody.
Seguimos pendientes de los mensajes que nos están llegando, los mensajes, las declaraciones por parte de la NASA. Por cierto, estamos también atentos a los mensajes que ponen en nuestro canal de YouTube. Vemos que muchos están pidiendo al propio Avi Loeb como presidente de la NASA. Les decimos que cuando acabe esta señal en directo vamos a tener más entrevistas y también van a ver la entrevista que hicimos al propio Avi Loeb hace apenas una semana, en un momento de mucha controversia, en un momento en el que vemos también que muchos espectadores, mucha gente nos está creyendo estos mensajes por parte de la NASA. Sigan insistiendo en que el 3 Atlas es un cometa. Atentos a nuestros mensajes. Pueden seguir, por cierto, toda la comparecencia en nuestro canal de YouTube. En paralelo, nosotros seguimos escuchando a la NASA. Estas son sus respuestas, sus explicaciones sobre el 3 Atlas.
To the phone bridge, our next question comes from Ken Chang with the New York Times.
Hi, thank you. This is for Tom and Nikki. One, of the measurements made so far, what is uniquely different about this comet, other than the trajectory, of course? And two, since perihelion, it looks like there are multiple jets. I was wondering if you could talk about that and the speculation that it might have exploded. Thank you.
Go ahead.
Yeah, thanks, Ken. So some of the differences I already mentioned is the ratio, the carbon dioxide to water ratio, the nickel to iron ratio. Also, there were ground-based observations noting that the polarization of the light reflected off the dust was also unusual. So that's telling us some interesting things about the dust. There are other indications that the physical properties of this dust, maybe the grain size distribution, might be different from the sorts of things that we're used to, the appearance of a sunward tail.
Siguen planteando más preguntas a la NASA en un momento en el que, como saben, bueno, el 3 Atlas ya pasó su perihelio, ya pasó a su punto más cercano al Sol. Estamos ahora mismo a 19 de noviembre, es decir, queda un mes para que este 3 Atlas pase a su punto más cercano a la Tierra y están preguntando sobre esto a la NASA. Están preguntando sobre el paso por el perihelio y también una de las últimas teorías que ponía sobre la mesa el propio Avi Loeb, se lo hemos contado día a día en Negocios Televisión, estos chorros que estarían saliendo del 3 Atlas y que, bueno, pues también hacen pensar, o el propio Avi Loeb decía que podrían hacer o podrían dar pie a que tuvieran cierta tecnología. La NASA responde también a estas acusaciones.
It does take some time to figure out, because it takes time for the actual event that happens on the surface to propagate out to a distance where you can see it with a telescope, but people are going to be mapping what jets there are. It doesn't necessarily mean there was an explosion. Jets can also just mean there are particularly active areas on the surface of the comet where more volatile stuff is evaporating in that one spot than elsewhere and jetting out. We saw this a decade ago with the ESA Rosetta mission at Comet 67P. It got up close and personal with the nucleus and saw frequently that there were jets coming out from specific places on the nucleus of the comet. So that could very well be what's going on here. Can't tell for sure, but that's the sort of thing we've seen before.
The other thing I just want to say that we're expecting to see as more stuff gets thrown off this comet in these jets is at those warmer temperatures, additional things can bake off of it, additional gases can bake off, and so we do expect the composition of the coma to potentially change, or those jets to change over time. And looking at the details of what other molecules we detect beyond the carbon dioxide and water we mentioned is also going to be interesting, especially for that sort of like, what was this the area in this, what was this stuff made of in the area it was made, like long time ago.
Right. Our next question is from David Chandler with Sky and Telescope.
Yes, a couple of things. Have you any of these observations showing you anything about any non-gravitational accelerations at this point? And also, can you say a little bit about coming attractions? What observations are in the pipeline that have been made but not released yet? I think the MRO high-rise observations, has that been released yet? And what else is there that's either in the can and waiting to come out, or observations that will be made over the coming weeks as the object comes closer to Earth?
Mm-hmm. I can answer some of that about the non-gravitational accelerations. This is something that we look very closely at for every comet because that's always something that happens. And just to back up to explain what the question is that as comets evaporate, they are...
Seguimos con este turno de preguntas para la NASA. Seguimos, bueno, pues analizando todas las teorías que hemos ido contándoles día a día en Negocios Televisión, también con este programa especial que hacemos siempre a eso de las 3:30 de la tarde, sobre la última hora del 3 y Atlas. Venimos avisándoles mucho durante la última semana de esta aceleración no gravitacional. Se dice que cuando el 3 y Atlas pasó por superhelio, pasó cerca del Sol, había acelerado. Claro, esto, bueno, pues ha desatado mucha controversia. La NASA también responde a estas acusaciones.
There are some changes to the orbit, but the uncertainties are still fairly large. It's difficult because we can't see the nucleus directly. It's difficult to get a very, very precise track on exactly where it's going. But so far, the non-gravitational accelerations have been very much on par with the sort that we see in solar system comets.
In terms of future observations, you know, this is a situation where, because this is only the third time we've had an opportunity to look at an object like this, everyone that is in control of a telescope wants to look at it because it's a fascinating and rare opportunity. I know that our colleagues from the Keck Observatory have looked at it. I believe that we're going to look at it again with JWST in December. We have some other ground-based facilities that are giving us additional compositional information as those additional molecules bake off.
Ojo con esto porque la NASA está admitiendo ahora que no son capaces de seguir la trayectoria del 3 y Atlas. Dice que no pueden obtener una imagen muy nítida del núcleo y que por eso, bueno, que su percepción es que este 3 y Atlas no está acelerando, pero a pesar de las imágenes que han mostrado y que vamos a repetirles más tarde, la NASA está admitiendo que no puede seguir la trayectoria del 3 y Atlas. Dice que hay muchas incertidumbres todavía, sobre todo porque no pueden acceder, no tienen una vista perfecta de su núcleo. Vamos a seguir escuchando a la NASA. Esto es muy importante. Dice que no saben la trayectoria exacta del 3 y Atlas.
Be able to track it longer than anyone else, partly because of its ability to kind of look long and deep, rather than sort of across and wide, and the fact that it looks in the ultraviolet, so in the infrared, so it can kind of see the dark objects. And so I'm really excited about just sort of, you know, tracking it till the very end. Also noted we're downlinking data from missions. I mentioned Parker Solar Probe because I just heard before we came on that we'd got some data and we'd seen the comet. I haven't had time to look at the data yet, but all of those things are coming up as we are getting more and more data coming down to us from those missions. And then, as both Sean and Tom talked about, just really making sure we're sharpening up those images and really, you know, making sure they're calibrated. Right now we're putting out almost the raw images. We're putting out things quickly so everyone can see them, but we'll take some time and do some, you know, real sort of deep looking into those and do some more of the spectroscopy. Tom showed a really great example of kind of looking through the atmosphere of Mars, take out that hydrogen, take out the hydrogen from our solar system, and then let us look at the hydrogen that's coming from the comet. So we'll be doing a lot more of that as we move on to do great things with NASA science.
All right, that's a great lead into our next question on social media. Elijah on X asks, what kind of processing were the images subjected to and why did they need it?
You want to take that?
The images that were released received the sort of standard processing that we do between the raw data that comes down into a telescope. That, as Nikki said, you know, we need to make sure for scientific accuracy that they're calibrated against the other observations, and we account for anything that the telescope is doing in that moment. And so that it would be our standard set of calibrations and normalizations for a object of this type, which is to say a comet.
I can add a little bit more to that. As Nikki said, our desire was to get these
Seguimos atentos a los mensajes que llegan desde la NASA, atentos también a los mensajes que tenemos en nuestro canal de YouTube. Vemos algunos que dicen que siguen creyendo a Avi Loeb, otros que hablan de la burbuja de la inteligencia artificial. Están en lo cierto. A eso de las 10 de la noche vamos a comenzar programación especial mirando estos Nvidia. Vamos a contar también con nuestro compañero José Antonio Bizner. Nosotros seguimos mirando a estos mensajes por parte de la NASA y a la pregunta que estaban planteando ahora. Les estaban diciendo que cómo así el procesamiento de estas imágenes. Escuchaban ahora a la científica que, bueno, venía a decirnos que todavía tienen que elucubrar, que todavía tienen que terminar muchos detalles de estas fotografías que todavía están siendo procesadas. Vamos a seguir escuchando los mensajes, las explicaciones de la NASA.
Has yet to be done to figure out exactly what that scattered light contribution was and remove that from the image so that what we show in the image is entirely what was there in the sky and not something just made by sun glints off the spacecraft hardware.
Yeah, and sometimes I think you showed the Soho image where we actually stacked a couple of images because a single image you wouldn't be able to see it, it would be too faint, but if we stack a couple of images together then you can actually start to really make out what that comet looks like.
Okay, next, Gail on Facebook asks, how can an object like 3I Atlas come from so far, moving as fast as it is, and not hit anything?
Orbital dynamics and space is really, really huge. And so, you know, it is amazing to think about just how big even our solar system. And so to give you the Voyager spacecraft, Voyager 1, is now 1 light day away from Earth, which means when we send a command or we send a photon from Earth, it takes a full day for that photon to arrive at Voyager, and Voyager is only just outside kind of what we think of as the edge of our solar system. And so space is vast. Yes, this thing is moving quickly, and yes, it came from outside our solar system, but you know, the probability of it actually hitting something is so small. As everything has to align. It's also not quite in the ecliptic plane. It's not quite in like our normal, if you think about sort of looking side on at our solar system with the sun and then you put the planets kind of in a row. Normally everything sort of orbits in this plane. This is slightly tipped, not unusual because it's not gravitationally bound to our sun, but it's slightly tipped. That makes the probability of it hitting it almost even greater.
If I can play with a scale model solar system. If you make a scale model solar system where the sun and the Earth are 1 foot apart, that's about 1 foot. The sun is a P. The Earth, you need a magnifying glass to see, it's so small. The entire solar system will just barely fit in your house if you squeeze a little bit, and the next nearest star is over 50 miles away. So they call it space for a reason. Most of it is space.
Okay, we'll head back to our phone bridge. Our next question is from Brandon Spector with Live Science.
Hi, I wanted to ask about the age of the comet. You mentioned there's circumstantial evidence that it's much older than our solar system, but how can we constrain that age a little more, and what will that tell us if it is indeed much, much older than the solar system?
I can start that, but I'm going to pass it to Sean to talk about ages in the galaxy.
Okay.
So cutting to the end, the bottom line is going to be, it's probably going to be really hard to get a more precise figure from one object. I think what we're looking at in the future, as we discover more of these, when we get to the point where we have maybe a few dozen of them and look at the distribution and properties, we may be able to get a better handle on what the distribution of ages is. So what's going on here is that it takes the sun 240 million years to orbit around the center of the galaxy, and we're doing that with a neighborhood of stars. So we're all going around the center of the galaxy. The relative motions between stars in our solar neighborhood is sort of 10-ish, 15, and sorry, I have all these numbers in my head in metric because that's the way I learned them, but 10 or 15-ish kilometers per second. So what is that? That's about 25,000 miles an hour, I think. And 3I Atlas is coming through at a speed of 60-something kilometers per second, so that's 3 times faster.
Seguimos escuchando más preguntas sobre este 3I Atlas, ahora mismo cuestionando acerca de su edad. Decía este físico, decía este científico, bueno, pues que tienen muy pocas pruebas, que estamos en el 3I Atlas y hasta ahora, bueno, pues solo tienen 2 con los que comparar. Dice que están recabando muchos datos y que, bueno, que este estudio sobre el 3I Atlas también está dando muchas claves para lo que pueda suceder en el futuro. Tarde o temprano seguramente tendremos otro 4I. Seguimos escuchando estos mensajes mientras ya les avisamos que en los próximos minutos volveremos con la entrevista de Avi Loeb.
And so that's the circumstantial evidence that makes us think that 3I Atlas came from a solar system that had larger motions relative to our solar neighborhood and is older. But it is a circumstantial and probabilistic argument.
So I'm just going to take this opportunity to brag about our telescopes and the James Webb Space Telescope in particular.
Go for it.
This blows my mind. We have data from galaxies closer to the origin of the universe than we have data from rocks closer to the origin of Earth, right? In other words, like if you pick up the oldest rock that we have from Earth, it is further away from the origin of Earth in terms of hundreds of millions of years than the amount of time there was between the origin of the universe and the earliest galaxies that JWST has now observed. And that's part of this story of how well we understand not just the history of our home planet, but the history of the entire universe that it's a part of. And now this is just another part of that story of the local neighborhood that our solar system is a part of.
All right, our last question for today comes from X and asks if we can see grains of sand on Mars. How is the clearest photo we can see for 3I Atlas, what we've seen?
So because we're closer to the grains of sands on Mars, right? And so the JWST can only get like these single pixel blobs of the faintest galaxies, the furthest away galaxies in our universe. And because 3I Atlas is in our solar system, we can get the images and the compositional information with JWST. As it got closer to some of the planetary spacecraft Tom was talking about, they can't even see these galaxies, but because 3I Atlas was closer to them than they were to JW, they got really good images of the object as it passed by.
Right, as you said, we can image individual grains on Mars because we have spacecraft standing on Mars.
Right.
But even our closest spacecraft to 3I Atlas, we're still 19 million miles away.
And it's going too fast for us to send something there to intercept and get that close to it. So that's just not that we just don't have the. If we could. We would. We would be there up close and getting those grains.
All right, well, that's all the time we have for today. Thank you so much for joining us. Be sure to follow along with NASA.
Hasta aquí ha llegado esta señal en directo, estas explicaciones por parte de la NASA, prácticamente una hora respondiendo algunas preguntas en X, algunas preguntas en las redes sociales, no la nuestra. Ya les decimos que desde Negocios Televisión hemos intentado cuestionar, hemos intentado plantear preguntas, pero no hemos tenido esa suerte. Hemos visto imágenes inéditas del 3I Atlas, hemos visto también algunas explicaciones por parte de la NASA, por ejemplo, sobre estas teorías que hablaban de que tiene varios chorros, otras teorías que hablan de que hubo una aceleración no gravitacional cuando este 3I Atlas alcanzó su perihelio. Bueno, la NASA ha intentado ir echando balones fuera, hablaba también sobre su tamaño, sobre la comparación con el 1I Oumuamua o el 2I Borisov. La NASA dice, porque tienen una muestra muy pequeña y que poco a poco están recabando datos y están intentando también sacar conclusiones acerca de este 3I Atlas. Enseguida vamos a seguir con más expertos, vamos a seguir con más analistas, pero vamos a escuchar lo que nos decía Avi Loeb, el científico de Harvard, que hemos visto que ha mencionado mucho en nuestros comentarios en YouTube. Saben que, en las últimas semanas ha estado varias veces en esta casa, ha estado varias veces en Negocios Televisión y les emplazábamos nosotros al próximo 19 de diciembre. Va a ser el momento en el que 3I Atlas pase cerca de la Tierra, va a ser su punto más cercano a la Tierra, y el científico de Harvard nos decía hace apenas una semana que espera que no tengamos un regalo para Navidad. Avi Loeb hablaba de esta forma sobre el próximo 19 de diciembre y sobre el paso más cercano de 3I Atlas a la Tierra. Este es el mensaje que lanzaba sobre Navidad.
We will find the answer to the fundamental question, is it technological? Was this trajectory designed by some intelligence? Or is it a natural object that happens to be very rare and unusual relative to the rocks that we would have expected? And the answer will come in the coming weeks. It will get closest to Earth on December 19th. And that's just 6 days before Christmas. And my hope is that it will not deliver any unwanted gifts to us on Earth for the holidays.
Seguimos en Negocios Televisión escuchando las declaraciones por parte de Avi Loeb, escuchando las explicaciones por parte de la NASA y, como les decíamos, contando con los mejores expertos. Ya contamos con Darryl Seligman, Professor of Astronomy in Michigan State University. Hi, Darryl. Thanks for being here with us.
Thanks for having me. It's great to
have you here. I would like to know what is your answer about these messages from the NASA. What do you think about this explanation?
Yeah, no, this is super exciting. So it's really exciting to see that we have finally presented all of the data that we took on this object in the last couple of months to both the scientific community and the general public, because essentially what happened is that we have 3i Atlas discovered this very exciting interstellar object. We only have one shot at it. So the observations that we get now are the only chance in not only our lifetime, but the lifetime of the solar system to study this object, because it comes and goes and it's never coming back. And it's a time capsule of information from another planetary system outside of our solar system. And then it was as exciting as it was to kind of being part of the discovery in July 1st, we then had the unfortunate event where we basically weren't able to point our ground-based telescopes at 3i Atlas during the most interesting time when it was closest to the sun. You really want to look when it's closest to the sun, because that's when you get the most holistic view of the nucleus of a comet. And the great thing is that although we couldn't see it from Earth, all of NASA's space-based assets were able to look at it. And they just weren't able to release that information because of the government shutdown. So it's extremely exciting to get all the information released right now.
Daryl, I think that the question is clear. Can we trust in the NASA?
Can we trust? Sorry, could you repeat the question?
Yeah, in the NASA, can we trust in the image, the explanations about how the NASA, can we trust in them?
Right. Yes, absolutely. So I mean, this is kind of how science works. Usually, it's not just a big press release. So it kind of had to be this time because we had all of this information that wasn't able to get out because of the government shutdown. What's going to happen is that all of the data that is taken will be submitted to journals, scientific journals, and then peer reviewed. And then the statements that we make about the conclusions that we draw from that data about 3i Atlas will get peer reviewed by experts who work on comets and solar system objects and interstellar objects. So for sure, we can trust in this information coming from NASA, and we can look forward to the next several weeks for seeing what the exciting results and interpretation from that data are about 3i Atlas.
And Daryl, what do you think about 3i Atlas? Do you think that is an ordinary comet?
So that's a great question. So I do not think it's an ordinary comet in the sense that every comet is not an ordinary comet. So there are lots of ways to answer this, but 3i Atlas isn't an ordinary comet because it's from outside of our solar system. Comets usually behave in different weird ways, but if you look at the comets in the solar system, there are some trends that appear that 3i Atlas seems to have been an outlier with regards to. So 3i Atlas, for all intents and purposes, is displaying every phenomenon that we know that comets display. So it has a nucleus, a rocky, icy nucleus, which is expelling gas. And basically, by looking at that gas, it tells us something about the nucleus. So the reason we're able to make any statements about the observations that we have obtained on 3i Atlas to this point is because we have gotten very good at studying comets. So the fact that 3i Atlas is kind of behaving like a comet is the reason that we're good at getting measurements and observations of this object. It is not like a typical comet, though, because one strange thing, I mean, you just heard NASA's press release. So Tom Statler was saying some of the kind of interesting properties. To me, the most interesting property about this object is that it seems to be most of the gas coming off of it is not water. So the fact that we've seen a lot of CO2 driving the activity, carbon dioxide coming off of 3i Atlas tells me that it's potentially something very different from our regular solar system comets. And that one interpretation of that is that it formed in a similar manner to the comets in our solar system, but at a much larger distance from its host star. So where you basically need to be at a region of an exoplanetary system that's very cold to have cold temperature-wise, to have CO2 incorporated in the ice. So on the one hand, I'd answer you with 3i Atlas, yes, it is not like a typical comet because it has all these interesting properties that maybe is telling us something about how planet formation is different throughout the galaxy, but it is clearly a comet.
Daryl, what do you think about the size, the speed of the 3i Atlas? Why is so different from one Oumuamua or 2i Borisov?
That is an excellent question. So I think, okay, so to answer that question, we need to be more specific about what differences we're talking about. Another difference of 3i Atlas with both the Oumuamua and Borisov is that it was moving much faster when it entered the solar system. So that, I think, is telling you, basically, the faster an interstellar object moves through the galaxy, the older it is. Because as things orbit in the galaxy, as time moves on, they basically scatter off of things like giant molecular clouds. And the cumulative effect of all of these scattering events makes objects move faster. So I think the fact that 3i Atlas is moving so much faster, than Oumuamua and Borisov, is potentially telling you that it's a much older object, potentially even older than the solar system. And that really could be, what's exciting about that is that it could be telling you that the processes by which planets formed and comets get scattered and ejected that we know happen in the solar system, potentially were happening just as efficiently and vigorously in the Milky Way at its very earliest stages. So when the Milky Way was a very young galaxy, we were also making planets and comets the same way that we do them now.
And Daryl, we are talking a lot about this 3i Atlas because of Avi Loeb, this scientific of Harvard. What do you think about her hypothesis?
Well, I mean, I think that you just watched NASA's press release. It's pretty, I mean, the reason that we're able to get all of these exquisite measurements of 3i Atlas with our space-based assets and with the ground-based observations and do things like what I've been talking about, measure its speed at speed when it was entering the solar system, measure the composition, how we know that there's CO2. You heard Tom Statler at NASA talking about the weird properties of the dust grains, like the weird the polarimetric measurements were a little different than we normally see. It seems like maybe there are larger dust grains than in typical solar system comets. The fact that we are so good at making all those measurements is because we have been making those measurements of comets for decades. This object has, ever since we discovered this object, it has displayed every characteristic of a comet. So the reason that we're able to get these interesting measurements is because it is a comet and we have been studying it and measuring it just like we measure every other comet.
And Daryl, do you think that Avi Loeb is helping or is harming the scientific community?
I think that is a question that the scientific community in general feels be split on. So I think it depends on who you ask.
Well, waiting for more reports about Avi Loeb, I would like to ask you about if you think that we had a 4i in the future. You think that 3i Atlas will be the last?
For more interstellar objects in the future, is that what you were asking?
Yeah.
Oh, yes. So this is extremely exciting. So even just discovering Oumuamua in the last 10 years, I mean, not even 10 years, but approximately 10 years, if we discovered Oumuamua in Atlas, forgetting about Borisov even, that tells you that there's about one similar object in the inside of Earth's orbit at any given time that we're not seeing. And that corresponds to about 100,000-ish interstellar objects inside of Neptune's orbit. And if you go to the whole galaxy, we're talking about something like 10 to the 26 interstellar objects in the galaxy. So that means for sure there should be many more of these objects that we could detect. It is not at all like 2017 was special and that was the only time an interstellar object came through our solar system. We just managed to discover it at that point in time. So for sure there are other objects out there to discover, but we just almost contemporaneous with the discovery of 3I Atlas, we had the first light of the Barra-Rubin Observatory LSST. LSST in the Atacama Desert is going to look at the entire it is currently operating, it is looking at the entire southern hemisphere every night, basically, to about 5 orders of magnitudes more sensitivity than any all-sky survey that we've ever had before. And that means that we should be just that much better at discovering interstellar objects in the next several years. So I expect that we'll start discovering these objects at least a couple every year from now on.
And Daryl, what can we learn about these 3I Atlas for the future? How can help to the scientific community?
So one thing okay, I'm just getting excited because thank you for that question, because I've also been thinking about that. One exciting thing is that 3I Atlas, we're going to be able to look at it through the spring, maybe even into the summer. So we, as astronomers, we can get data on this fantastic object for several months. And there is data at any point in time on 3I Atlas throughout its trajectory is valuable. You heard the people at NASA talking about that. Data when we couldn't look from Earth, when it was closest to the sun, was super valuable because that was when the comet's at its warmest. However, you also heard them talking about, there was a question in the Q&A that they addressed about what was the processing like as 3I Atlas traveled through the galaxy. So we have an opportunity not only to learn about exoplanetary systems, but what happens to comets as they travel through the interstellar medium of the galaxy. So as we look at 3I Atlas as it kind of leaves the solar system, that's potentially going to tell you about material which is further in of the nucleus of the object, and maybe tell you about how that processing in the interstellar medium occurred on an interstellar object. That's like, effectively, that is something that we've tried to learn about in lab experiments for the last couple of decades, but the interstellar objects like Oumuamua, 2I Borisov, Atlas, and then all of the future ones we're going to discover, that gives us an unprecedented window into not only planet formation around other stars, but what is the environment like as these objects move in the interstellar medium.
And the last question, what can we expect from the 19th of December? Could we see a better image of these 3I Atlas?
Right, so for people at home interested in looking at 3I Atlas, it will not be, you cannot see it with just your eyes. So it's not a naked eye comet, but it is possible from some locations on the Earth that you'd be able to see it with a good amateur astronomer telescope. So you don't need a big fancy telescope like LSST or James Webb Space Telescope to see this object. It is possible, if you have a powerful enough amateur telescope, then just with an eyepiece to try to look at this object, if you're kind of in or close to one of the right areas where you could see it from. So I'd recommend definitely, wherever you are now, looking up when and where you could see the object from, and then trying to find a place which is far away from light pollution, so far away from city lights, and as high up as you can get to try to stake out a view on when it's close in December, when it's closest to the Earth. You don't also have to go that date. You could go basically starting after December 1st, but you know, the later weeks in December will be better, but you could potentially see it with an amateur telescope. In fact, I've been getting images that amateur astronomers are sending me with their telescopes pretty much every day. So can be a very valuable, not only can it be exciting for you to go and look at it, that can be a very valuable contribution to the scientific community.
Well, waiting for this 19th of December, Daryl, thank you so much for being here with us in Otros TV. It's a pleasure having you here.
Thanks for having me.
Thank you.